So this is a bit of a geometry problem. We've got this upside down parabola, negative x squared. Take a look at the graph, and since this can be factored, we see that the roots are at -2 and +3, and our job is to find the area in there. So a sketch of the graph. Has it at -2 and +3. There's parabola. And now estimate the area using 5 rectangles. So the first thing to do is take this interval from -2 to +3, which is a length of 5, and divide it into 5 pieces evenly. So that's going to be on the integers. And then the idea is take a rectangle with this as its base, so base length of 1, and make a rectangle that goes up and estimates the area under that curve. Well, if we want to do this as accurately as possible, I think what we should do is basically just take the middle of the rectangle and go up to the height, and that will give us the height of the rectangle. So as you can see, a little bit of it is poking out, so it's going to be an estimate. It's not going to be perfectly accurate, but there we go. And then for the next rectangle, so use -0.5, go up, and then that's going to be the height, and this is the base. So the next rectangle would look like this. And actually, if you look right here, there's a little bit that's not being covered, and then almost the same size is poking out on that side over there. So what didn't get counted over there and what got overcounted over there should sort of compensate for each other. We should get a pretty good estimate. And then the next one would be, so take a 0.5 and go up to that height. And then 1.5, go up to the parabola. And then finally at 2.5, go up to the height of the parabola. And there's our 5 rectangles. So for the area of a rectangle, you need to know the base times the height. Well, the base is 1 for each of these. That in fact is called delta x, or the change in x, and that comes from take the original two x values, 3 and -2, and subtract them. So that finds the length of 5. And then divide that into, here, 5 different pieces. So the width of each rectangle is a 1. And then to find the height, we need to substitute -1.5 into the function, and then -0.5 into the function, etc. So we'd have the area is approximately, so substitute -1.5 into the function, and then times 1 plus, so this one is going to be for when x equals -1.5, and then substitute that into the function. To save a little bit of time, I'm going to do that here rather than typing in things like -1.5 squared and 1.5, etc. So I'm just going to substitute -1.5. It's 2.25. And next, for this blue rectangle, the middle value right here was -0.5. So when x equals -0.5, I get 5.25. That's the height times the width of 1. And then substitute in the next one, which would be 0.5. So 6.25 times 1. So this one was for x equals 0.5. And then I'll continue down here. Plus when x equals a 1.5. And lastly, when x equals a 2.5. So with a 1.5, it's 5.25. And I'll bet you the next one's 2.25. Yes, because it's symmetric. Okay, then we need to add these up. So 2.25 actually showed up twice, plus 5.25 actually showed up twice, and then in the middle was a 6.25. Grand total area, 21.25. And then, is it possible to have the graphing calculator check our answer? It sure is. Right here under calculate, you go second calculate, and this one is find the area under the curve, number 7. Have it start at -2 as the lower limit, and the upper limit is 3. Not only finds the area, but watch this. Ooh, it shades the area. So the actual answer is 20.8, and we got 21.25. So these little parts right here that are poking out, or this little blank area, that's what's causing a little bit of error.